All right, welcome back. Lesson number 2 this week. This time we are going to be talking about the sum or difference of two cubes. And a cube means an exponent of 3. So something like x to the third power is a cube. But also we have numbers that are cubes, like the number 8, the number 27, the number 64, the number 125. Those are all cubes because we can find a number multiplied by itself 3 times that equals each one of those things. So for example, 2 to the third power, 2 times 2 times 2 is 8. 3 to the third power is 27. I'm writing it right over where you put your name, which is kind of silly. 4 to the third power is 64. 5 to the third power is 125. Okay, so these are perfect cubes, is what they're called, which means a number multiplied by itself 3 times and it's equal to something else. So these are going to be the important thing for this lesson, because we have to now, instead of looking for perfect squares, we are going to be looking for perfect cubes. And this one is significantly more challenging because we have some pretty complex rules to follow about how we set things up. And I'm just going to highlight them here in the box. So you're probably looking at that saying, oh goodness, there's signs and letters and numbers and there's a whole bunch of them and they're very similar. How am I going to remember that? Well, the key to remembering it is this word down here, SOAP. SOAP stands for, the word SOAP stands for same, opposite, always positive. Okay, so there we go. That's how we get SOAP. Same, opposite, always positive. And if you can remember that, then you're going to be able to do these just fine. All right. So the key here is you have this form here that it has to be in. So we have to have something that is a to the third power plus b to the third power. And then it's going to be equal to a binomial, a plus b, times a trinomial, a squared minus ab plus b squared. And you're like, how am I going to remember that? Well, you're going to remember it because of SOAP. And you're like, well, what's a and b? Well, a and b are just the thing that you have to multiply by itself 3 times to make the perfect square. So for example, up here, if I see the number 8, a or b is going to be 2. If I see the number 27, it's going to be 3. If I see 64, it's going to be 4. If I see 125, it's going to be 5. If I see x to the third, it's just going to be x. All right? So these are things that we want to just watch for and identify. All right? So if we just look at this first example, if we look at the first example, we have x to the third power plus 8. Well, I can look at that and say, hey, my a is x and my b is 2, because x to the third is our a term, 8 is our b term, and I know that 8 is 2 to the third power. And I know that x to the third power, or is just x times itself 3 times, right? So now I just have to think about, all right, how do I put this into this form? And I've got this little cheat sheet in the box over here, but I have to remember that if I think about the form, it's A, B, and then it's A, B, B. So let's see did we get that right? So we've got A, B, B, B. And it's the same in both different forms, and that's where it's really important to remember SOAP, same, opposite, always positive. Because we're going to look at the sign that's between the two terms in our original problem. In this case, it's a plus sign. And if it's a plus sign, that means my binomial is going to have the same sign. So I'm going to put a plus sign here. The first sign in my trinomial is going to have the opposite sign. So I'm going to put a minus sign here. And then the final sign in my trinomial is always positive. So this one's always positive. So that's how we can remember. Same, opposite, always positive. And that's how we remember the signs that we need to put in there. Okay? Now, we just have to fill in the rest, and we've got A's and B's there, right? So all we have to do is say, all right, my A is X and my B is 2, so this one's going to be X plus 2. Whoops, wait a minute. I forgot something. Anybody see what I forgot? I forgot the squared here. So there we go. And then my first term in the trinomial is going to be X squared. My last term in the trinomial is going to be 2 squared. And then my middle term is going to be A times B, or I like to do it the other way around because I want to put the number before the variable, so it's going to be 2x. All right, there's only one other thing we need to do with this before we're really done, and that is just simplify that final term in the trinomial to be 4. Okay, so there we go. There's our answer. That's how we can factor the sum of 2 cubes. You're probably thinking, oh my gosh, I'm never going to be able to do this. Yes, you will. You'll be able to do it. It just takes a little practice. All right, step 1, identify A and B. A is Y. English teachers wouldn't like that because they'd be like, no, A is A. No, in this case, A is Y. And B is, well, 27 is 3 times 3 times 3, so our B is 3. And then if we just write down our general form, we have A, B, I'll get it right this time, A squared, AB, B squared. And if we think same, opposite, always positive, the same sign would be a negative sign or a minus sign. The opposite would be a plus sign, and then always positive is, well, that's positive. Okay, so then we can just plug in the numbers and letters that we have, right? So we have y minus 3, and then we have y squared plus 3y plus, let's save ourselves a step here. Well, what's b squared? What's 3 squared? Well, it's 9. So I'm just going to plug in the 9. So there we go. We're all good. All right, so these are relatively straightforward examples because we start with a term that is just a variable to the third power. If you look at this next example, we're starting with a number in front of the variable or a coefficient in front of the variable. So we just have to be a little bit careful here. But if you remember from up on top where your name is, what I wrote up there, 64 is 4 to the third power. And x to the third is just x to the third power, right? So we can identify our A as 4x, because if we multiply that thing by itself 3 times, we're going to get 64x to the third power. And our B is 1. And then let's just think about our general form, A, B, A squared, AB, B squared. See the pattern? Okay, SOAP, same, opposite, always positive. Now let's just plug stuff in. So we have 4x plus 1. Now this is where it gets a little tricky. A squared, that's 4x squared. And so we got to be really careful here because we have to square the 4 and the x. And then this next one is 4x times 1. In this case, it's just a 1, which is nice. It's not hard to do. 4x times 1, so that's just 4x. And then the last term is just 1 squared, or 1, right? So we only have one thing to simplify now. And we have the first term in our trinomial to simplify. And if we take 4x and we square it, it just becomes 16x squared minus 4x plus 1. So there we have it. There is our factored form of 64x to the third plus 1. All right, if you doubt this, just set up a little box method with boxes that look like this and plug those two things in there and do all the multiplying and combining like terms, and you'll see you end up going right back to 64x to the third. All right, how many do we have left? Oh, just one left. All right, so this one, you might notice a pattern with all these assignments so far that every single one of them has something to do with factoring by GCF first. And this one does. And the thing that we need to look at is 54 and 16 and realize that neither one of those are a perfect cube because there's no number multiplied by itself 3 times that equals 54 or 16. But if we divide both of them by 2, so if we divide everything by 2 here and bring this 2 outside, we end up with 27a to the third minus 8b to the third. And now the 27 and the 8 are perfect cubes. So we can identify our a and our b. Ooh, we should have probably chosen different variables instead of having a's and b's. So don't get confused by the fact that we have a's and b's in our problem here, and we have a's and b's that we're going to be talking about for our general form. We'll keep it straight. All right, so a, if we have 27a to the third, well, that's going to be 3a. And 8b to the third is going to be 2b. Maybe it's not. That's a Shakespeare joke. That wasn't very good. All right, so now we have to think about our general form. So we have a, b. Again, don't let the a's and b's confuse you. A squared, ab, and b squared. All right, now you might notice something right away. This one's going to be a little trickier because both the a and the b have a number other than 1. And actually we have variables in both of them. So this is going to get a little bit tricky. But first things first, let's remember SOAP. So we want the same sign, the opposite sign, always positive sign. You do know I'm referencing this when I say same, opposite, always positive. Hopefully that made sense up above. All right, so then let's plug these things in. So our binomial is generally fairly simple. All we have to do is put the a and b in there, right? So we have 3a minus 2b. But then when we get to the trinomial, that's where it gets a little tricky because we're doing 3a squared. Well, that's just 3a times 3a, so that's 9a squared. And then we have plus a times b. Well, we just have to multiply our a and b together. So 3 times 2 is 6. Well, the a and the b are just going to stay a and b. And then our last term is b squared, or 2b times 2b, which is just 4b squared. Okay, so that's not so bad, right? If you just are careful and pay attention to your exponents and your signs and numbers and things like that, you should be perfectly fine with this. But the only problem is you're gonna have to memorize a couple little things. You know, and the main thing you have to memorize is the general form, ab, a squared, ab, b squared, and then SOAP. If you can remember those two things, if you can memorize these two things, then you'll be able to figure this out.